Hello students. Student, in the previous lecture just we have discussed the property number 2 that should be related to the sine inverse of 1 upon x, that should be written as cosec inverse x, cos inverse of 1 upon x, that should be written as sec inverse x, as well as we have to also discuss about the tan inverse of 1 upon x, that should be written as cot inverse of x. In certain conditions we have to get the result. In the very first part we have to say that modulus of x is greater than or equals to 1. Similarly, in the second part of the property number 2, again we have to describe modulus x is greater than 1, and in the last section tan inverse 1 upon x will become cot inverse x when we have to take the x is greater than 0. So these conditions are to be the somewhere very important. We have to just see the explanation of these properties, but just defining the two kind of facts, and that facts are already used in each and every kind of property in this property number 2, and in further properties we have to see these logics one by one here. Is it to be clear? So now today student we have to just start the next and the very important property number 3. After that we will also discuss the fourth property. In this video we are going to discuss the two kind of property. A very simple thing in these two properties are to be there. That's why there should be no problem is to be there to understand the property, as well as we have to use the result to simplify the questions, as well as you can just get the answer by using the property only. So in this way you can just calculate the answer, but first of all we have to just write down the property third property. So just we have to describe the property number 3. In this property number 3 we have to just write down the property first of all, then after each and every part is to be get explained in a very detail. So basically what is the statement of property number 3, we have to see this thing. Then in this case we are saying that sine inverse of minus x, that should be written as minus of sine inverse x, minus of sine inverse x, and here you can say that x belongs to minus 1 to 1, no problem, because you know very well about the domain. Similarly, the cos inverse of minus x, that should be written as pi minus cos inverse x. Student, how we will get these type of results? We can just prove each and every thing in a very detail, but before that we have to write each and every section that should be discussed in this property number 2. Here again x belongs to close interval minus 1 to 1. Third part we are saying that tan inverse of minus x, tan inverse of minus x is to be get written as tan inverse of x, where you can take x belongs to R. Similarly, in the fourth section we are saying that cot inverse of minus x will become pi minus cot inverse x, pi minus cot inverse x, where again x belongs to the R. Finally, the next fifth part we are taking for the sec inverse of minus x, then it is to be also written as pi minus sec inverse of x, where x belongs to R minus minus 1 to 1, because these are said to be the domain of these functions, and in both the side you can check both the functions are sine inverse, cos inverse, means no changes are to be there, then definitely you can write directly the domain of these functions here. So easily you can just remember the thing. Next and last part of this property, that should be written as cosec inverse of minus x, that should be written as minus of cosec inverse x. Again we are saying that this x belongs to the R minus of minus 1 to 1. So in this property these sections are to be defined. Now one by one we have to know each and every proof how the particular kind of expression is to be get obtained, and you can just see one thing. Here this minus sign is to be just written outside this function. Here this minus sign will be consumed as pi minus cos inverse of x. Here you can see that this minus sign is just written outside of this function, and similarly in the remaining of the result somewhere we have to write the pi minus, somewhere we have to write the direct minus sign outside the function. But how and why we are just writing this type of concept here, we will just see the proof of each and everything. Before that, student, pause the video to note it down this property. One by one we have to see the proof how the particular property is to be get proved, and then after you can basically understand the basic meaning of these properties. Then after we will discuss the sum of examples also, and by using that examples you can just understand the property. So one by one now we have to see the proof of each and every property. So the very first part is to be written as sine inverse of minus x, that should be written as minus of sine inverse x. Now we can see the proof of this part. Then let first of all we have to take sine inverse of minus x as another angle y. Let is it to be clear, because Here the domain is to be get defined already -1 to +1. Then we can take sine inverse of minus x as y, and you can write also like this: minus of sine x will be written as sine y here. Now this x will be written as minus of sine y. And one important section I think you know very well. We know that sine of minus theta, sine of minus theta will be written as minus of sine theta. This thing I think each and every student know very well, because in class 11 such kind of properties already you have go through these type of properties. So you can just write like this. In this section you can write sine of minus y. Now one more important thing that should be important here, student. In the case of sine, suppose this sine x will give the answer as negative. Then some of the students says, sir, why we are doing like this? We can say that this particular sine function will provide the answer negative in the third quadrant as well as in the fourth quadrant. So according to the given situation, you can say that this is the first quadrant, second, this one the third and fourth. There are fourth quadrant. So according to this situation, minus x equals to sine y, you will get the answer either in third quadrant or either in fourth quadrant. So you can take the value of this y in the third or fourth quadrant. But a very important thing, student, in this case you cannot take these quadrant, you cannot select this quadrant. Why? Because you know very well about the principal value of sine inverse x. Principal value of sine inverse x, that should be taken from minus pi by 2 pi by 2, means these particular principal value says that it remain only in the first quadrant. Is it to be clear? So definitely if we are moving in the third and fourth quadrant, then suppose this particular thing and this particular sine inverse has the domain or principal value in the third or fourth quadrant, then you can just write down the answer as pi plus y, or you can say that this is written as 2 pi minus y, no problem. But in this case no particular permission is to be there to move in third and fourth quadrant, because here the principal value of sine inverse x you know very well, that is minus pi by 2 to plus pi by 2. So some of the student has the logic like this: sir, why we are not calculating the value of this sine y as negative? Then you can just take the value in third and fourth quadrant. So student, you cannot take this job, because you know very well about the principal value of sine inverse x, because the permission is not said to be allowed as per the principal value. So according to the principal value we have to do the job. That's why we are saying that to remain in this principal value we have to write like this: x is minus of sine y. According to this part you can write like this: x equals to sine of minus y. Is it to be clear now? Now student, you can just say that here minus y is to be then, and sine will be shifted here, then sine inverse of x will become of minus of y. And you can say that y is what? So you can check y is sine inverse of minus x. So sine inverse of x will become minus of sine inverse minus x. Now this minus is to be get shifted. Then you can say that sine inverse of minus x will be written as minus of sine inverse x. So student, we have to just satisfy the principle always. Without principle we cannot take the inverse of any trigonometric function, because the function is not said to be bijective. That's why we have to just keep in mind the principal values. Is it to be clear? That's why we cannot move in this third quadrant as well as in the fourth quadrant, because the permission is not said to be granted as per the principle of sine inverse x. Is it to be clear? So whenever the permission is to be get granted, but it will depend on the basic principle of that particular type of inverse trigonometric function, and we will do the job in the sum of part also. But where the permission is to be there, then you can just do this job. Otherwise just we have to do the particular calculation and by using such type of properties. Is it to be clear? So I think the very first part, that is sine inverse of minus x, will be written as minus of sine inverse x. Then how we will get this result? You can see the proof in a very systematic way. And now we will take the second part, that is cos inverse of minus x. And I think you know very well, cos inverse of minus x will be written as pi minus cos inverse x. Then how the particular result is to be get derived, we will take this part. So in the second part, cos inverse of minus x will be written as pi minus cos inverse of x. Then we have to see the proof of this thing, how the result is to be get written like this. Now, student, first of all, you know very well about the principal value of principal value of cos inverse x, that should be taken from 0 to pi, means here the cos inverse x will give the permission to move in the first quadrant as well as in second quadrant, because 0 to pi means you can just cover the two quadrant, first and second. Next, here just again we are taking, let cos inverse of minus x will become taken as y, and now you can say that minus x will be taken as cos of y. Now, in the previous section, just we are shifting this minus sign here, and here minus of cos y will be written. But you know very well one important result, and again we have to specify the result from the trigonometry. We know that cos of cos of minus theta is again said to be the cos theta. So definitely, student, this negative sign will not be consumed. As per the previous proof, sine inverse, this minus sign will be consumed, because where the property says the sine inverse sine of minus theta will be written as minus of sine theta. But here in this case, minus theta has doesn't means, because again this is to be get converted into theta, so there should be no problem. Now, how this particular minus sign is to be get consumed, here we have to see. So now we will see the principle. Principle says you can move in this first quadrant as well as in this second quadrant, because here this is pi by 2. Here you can start, and here you can say that the pi. So 0 to pi, the principle will allow in this cos inverse, means inverse of cos will be allowed from 0 to pi. Now, now the student, here you can just say that x will become minus of cos y, no problem. Now you can write the minus sign as like this, cos of pi minus y. You can write like this, because you can just, and you can also write like this also. This cos either you can convert like this, or you can just convert like this, cos of pi plus y. Both the expression cos of pi minus y and cos of pi plus y are moving in either in second quadrant or third quadrant, because here this pi minus y will lie in this quadrant and pi plus y lie in this quadrant. So in this third quadrant, if we are moving, then definitely the principle does not satisfy here, because out of pi we cannot go for the inverse of cos. Definitely we will move only in the second quadrant, so we will not take this case, not taken. We will not take this case, because you cannot move in the third quadrant, as principal value of this cos inverse x does not allow the permission. So here we have to write only this way. So now student, this particular part cos of pi minus y will written as cos of cos of minus of cos of y. So now you can say that pi minus y is what? Pi minus y will become cos inverse of x, and y is what? You can say that pi minus cos inverse of x. So in this way you can just derive the result, but before that we just know about the quadrant theory, and we have to know about the principal value, because these things are to be depend on the principal. Means inverse of any trigonometric function, and inverse of any trigonometric function will be only possible for the restricted domain. That's why we cannot take each and every real number for the inverse here. So according to the principle, just we have to take the inverse. Means in which quadrant you can move, in which quadrant you cannot move for the inverse, just it will depend on the in principal value of the given ITF or inverse trigonometry functions. So why and how this particular answer is to be get written as pi minus cos inverse x, you can just think about this part. Now a very suitable example, suppose we have to just take here. Suppose any question is to be there, we have to calculate the value of cos inverse of minus half. Suppose this particular value is to be get asked here. Then first of all we have to use this property cos inverse of minus x. Then this particular part can be written as pi minus cos inverse of 1 by 2. And I think each and every student know very well cos inverse 1 by 2, because the 1 by 2 value of cos will be occur at the angle 60 degree, means pi by 3. So you can give the answer as pi minus pi by 3, and pi minus pi by 3 will be become 2 pi by 3. So in such type of questions, if any of the negative sign will be arises inside the any in inverse trigonometric function, then how this particular negative sign is to be get processed, so that we have to learn this property, and we have to use this property to simplify the questions. So many questions are to be also that in exercise 2.1, where we are just solving the question in the different way, but you can use this particular property in the exercise 2.1 also, where any of the negative sign is to be there, then how this particular negative sign is to be get removed, and how it is to be get processed. You can see these things by using the properties. So now student, you can see many more examples also in your NCERT, and you can just use the property to give the answer of such kind of questions. Is it to be clear? Now we will take the next and the third one, that is tan inverse of minus x. We will take the next tan inverse of minus x is to be written as minus of tan inverse x, and here you can say that x belongs to R, and here you can say that principal of tan inverse x. Again, principal of tan inverse x will be from open interval minus pi by 2 to plus pi by 2. Is it to be clear? Now let we can say that tan inverse of minus x will be taken as y, then tan of y will become minus x and x will become minus of tan y. Now the thing is what? The tan function will provide the negative answer, though we can just select the quadrant. So you can just say that this is x axis and y axis. So in the second quadrant and in the fourth quadrant, the tan function will provide the negative answer. So here in this quadrant and in this quadrant, the tan will provide the negative answer. But first of all, we can check whether we can move in these quadrants or not. It will depend on the principal value. So principal says that minus pi by 2 to plus pi by 2 means only first quadrant permission is to be there. So there should be no particular movement is to be obtained here in second or fourth quadrant. That's why we can use the property. Now you can say that again, we know that tan of minus theta will become minus of. Then this property we can use to consume this negative sign, because in the different quadrant you cannot move here. So definitely this will be written as tan of minus y, and finally you can write the minus y equals to tan inverse of x, and you can say that y will become minus of tan inverse x, and here you can say that this is y is what? Tan inverse of minus x. So you can say that tan inverse of minus x will become minus of tan inverse x. So this property you can just verify here, and just we can see the proof of this property in a very systematic way. But we have to keep in mind the things. Suppose we have to take an example. Suppose we are just providing the answer of this part. Suppose this question is to be given, we have to just calculate the answer of tan inverse of minus root 3. Then what should be the answer? So definitely tan inverse of minus root 3 is to be get evaluated. Then first of all we have to see this negative sign. We have to see this negative sign. So for the negative sign we can say that the property will be used and it will be written like this, tan minus of tan inverse root 3. So root 3 value of tan inverse is for the angle 60 degree, and there should be pi by 3. So the answer in this case you can return here minus of pi by 3. So in such kind of questions, like the questions are to be given in 2.1 also, you can use this property to simplify the questions. But we have to remember the proper expression, and we have to see each and everything carefully, so that you can able to use the particular kind of property in the particular kind of question. Is it to be clear? Next we will take here cot inverse of minus x. Before that, pause the video to note it down. Next we are taking cot inverse of minus x. That should be written as pi minus cot inverse of x. How this expression will get written? So basically again we have to take let cot inverse of minus x equals to y, then x will become minus of cot y. Now there are two criterias. Now there are two criterias where we can just consume this negative sign here. So definitely principal value of cot inverse x you know very well. Principal value of cot inverse x, I think each and every student know very well about this part. 0 to pi open interval means again there should be a step where you can just move in the second quadrant also, and in second quadrant this cot will provide the negative answer. So definitely you can just make the quadrant, and here the permission to move in second quadrant is to be there. This is the third quadrant, this is the fourth quadrant. So here there are two quadrants where the cot will provide the negative answer. So here the permission will be there. So you can write here pi minus y. Is it to be clear? In this case, this permission is not said to be there, because in fourth quadrant the principle does not satisfied. So you can say that this x will be written as cot of pi minus y. Cot of pi minus y. So definitely in this case you can write here pi minus y equals to cot inverse of x, and what is y, that should be written as pi minus cot inverse of x. Is it to be clear? So easily you can just obtain the result just by using the principal value of each and every trigonometric function. Is that to be clear? So somewhere we have to write the result as pi minus, somewhere we have to write down the direct result as minus sign will become outside the function. Then how these processing will be there and how the process of these functions are to be there, we can just understand the thing in a very systematic way. Is it to be clear? So the next sec inverse we will take, student. Before that, pause the video to note it down. Next we are taking as sec inverse of minus x, that should be again written as pi minus sec inverse of x. Is it to be clear? Then how the result is to be get proof? So we have to see the proof of this part, and for this part we can say that let sec inverse of minus x equals to y, then minus x will become sec of y, and here x will become minus of sec y. Now we can check the principal value. So I think each and every student know very well about the principal value of sec inverse x. That should be 0 to pi close interval except of pi by 2, means definitely again you can just move in the second quadrant. This is the permission to move in the second quadrant. So definitely in the second quadrant, in this second quadrant, this sec will provide the negative values. So you can move here as per the principle says. So here you can just calculate the value as pi minus y. So from here you can just write this minus of sec y as sec pi minus y. So sec pi minus y will be again written as minus of sec y. Now you can just take the inverse here, pi minus y will be written as sec inverse x, and here the y will written as pi minus sec inverse x. So in a very systematic way you can just derive the particular result, but before that we have to keep in mind the principal values, otherwise you will not get the answers of these type of things. Is it to be clear? So definitely student, whenever we have to do the proof, then we have to keep in mind the principal value as well as the domain of each and every inverse trigonometric function, because the particular kind of inverse trigonometric function is only defined for the certain cases where we have to make the function 1 on 2 bisective. Then definitely we have to apply the some restriction on the domain. After that we have to just define the inverse of the trigonometric function, so that we have to keep in mind the principal value as well as the domain whenever we have to calculate the property of related to the inverse trigonometric function. Then somewhere we have to write pi minus, somewhere we have to directly write the minus sign outside the function, but each and everything you have to just understand by using the principal value. Next and the last part we have to take here, cosec inverse of minus x. Cosec inverse of minus x, that should be written as minus of cosec inverse x. No problem. Here you can just see the proof. Then let cosec inverse of minus x will be taken as y, then definitely cosec of y will become as minus x, and x will be taken as minus of cosec y. Finally student, this minus sign is to be get consumed by applying which kind of theory? Then you can understand that principal value of cosec. I think each and every student know very well about the principal value of cosec inverse x. Principal value of cosec inverse x is to be taken from minus pi by 2 to plus pi by 2 except of 0, means again there should be no criteria to move in the different quadrants, and definitely cosec will give the negative value in third and fourth quadrant, and no criteria is to be get defined in the principal value. So now what we will use here, you can say that we know that cosec of minus theta, cosec of minus theta will be again written as minus cosec theta. So definitely we can use this situation. So here this minus sign will be written inside this function as cosec of minus y. Now you can say that cosec inverse of x will become minus of y, and y is what? Cosec inverse of minus x. So you can write here cosec inverse of minus x will become minus of cosec inverse x. So easily you can just verify the properties, and in this property number 3 student, each and everything you can just think these should be based on the principal values. As per the principal value you can just check in which quadrant you can move, in which quadrant you cannot move, and according to that we have to write the result somewhere as pi minus, somewhere directly minus sign is to be written outside. Each and everything you can just check as per the principal value of cosec and each and every inverse trigonometric functions. Is it to be clear? So I think the properties are the property number 3 is to be clear to each and every student, and you can just simplify the question, student, of exercise 1.2, where in some of the questions you can check here the negative sign is to be given, then how this negative sign is to be get processed. So for each and every kind of inverse trigonometric function we have to do the processing of in minus sign, then by applying these properties you can just simplify the answers. Is it to be clear? One more property, student, we will just discuss as the property number 4. Before that, pause the video to note it down. This proof of this cosec inverse of minus x equals to minus of cosec inverse x. Now we will take the very important and very simple property, that is property number 4. Here the sequence is not said to be fixed. Some of the students says, sir, says this is the property number 4, but in this book this is to be given as property number 2, 3. So this is not a fixed sequence. You cannot just confuse related to this is the number of property, which means the numbering of property you can just adjust here, no problem. In this property we are saying that very first part, sin inverse x plus cos inverse x will become pi by 2. In this second part we are saying that tan inverse x plus cot inverse x is again said to be pi by 2. In third part we are saying that this cos inverse this sec inverse x, this sec inverse x plus cosec inverse x will be written as pi by 2. A very important property and very simple thing is to be given here. We will just see the proof, but before that we have to see the basic property, in which we have to just return the things as sin inverse x plus cos inverse x will become pi by 2. Tan inverse x plus cot inverse x is to be get written as pi by 2, as well as sec inverse x plus cosec inverse x will be written as pi by 2. Now we have to see the basic proof of each and every thing that should be written in the property number 4, and basically we will use these things in the basic kind of questions also, where how the particular thing is to be get processed and how the particular thing is to be obtained, we have to see each and everything. So we will see the proof of 1. First of all we have to just see the proof of 1 here. In this case it is to be written as sin inverse x plus cos inverse x will become pi by 2. We have to see the proof of this property first of all. Then let sin inverse of x equals to, suppose, any angle A. You can take any angle A as sin inverse x. Then x is what? X will become sin A. X will become sin A. Now student, a very important case related to the transformation, I think you know very well, because in this in the previous class 11, just you can say that sin pi by 2 minus theta is cos theta, cos pi by 2 minus theta is sin theta. So such kind of transformation you can just apply in this case also, and this particular sin A will be written like this, cos pi by 2 minus A. This thing is the very important. Student, here sin A will be written as cos of pi by 2 minus A, because cos pi by 2 minus theta is already said to be the sin theta. So in place of sin A you can write like this. Now you can just simplify, and here you can say that x will be written as cos pi by 2 minus A, and this cos will be moved in this side, then it will become cos inverse x. Here pi by 2 minus A. So A is what? Sin inverse x. So here in place of A you can apply the sin inverse x, and this is to be shifted here, then easily you will obtain the answer cos inverse x plus you can say that cos inverse x plus sin inverse x will give the result as pi by 2. So easily you can just do the proof of this kind of result, sin inverse x plus cos inverse x equals to pi by 2. And similarly you can do the proof of this thing. Easily you can see the proof of this thing also. Again the similar type of theory we have to apply. Let tan inverse of x we will take as angle B, then you can say that x will be what? X will become tan B, and this tan will be written as cot pi by 2 minus B. Again the transformation you can just use here. As per the trigonometry you have to know about the transformation. So x equals to pi by 2 minus B, then definitely this cot will shifted here, then it will be cot inverse x, and here you can say that pi by 2 minus B. B is what? Tan inverse x. So easily you can say that tan inverse x plus cot inverse x will give the result as pi by 2. So again you can do the proof of this second part easily here. Similarly you can do the proof of this third part also. Again in the third part in the third part, let sec inverse of x equals to any angle c, then x will become what? Sec c, and you can write this part as cosec pi by 2 minus c, because cosec pi by 2 minus theta is sec theta, you know very well. Now again this cosec will be shifted here, then it will become the cosec inverse x, and this is written as pi by 2 minus c. So we are taking the inverse here because just we are taking the values in the domain. Is it to be clear? Means certain domain is to be get defined already, and we will not check for the domain directly, we have to take the inverse. Then you can just think about this part in this NCERT, means according to the domain we have to take the values. That's why there should be no problem when we have to take the inverse. Otherwise, before taking the inverse, means this part is to be shifted here, then we have to check whether inverse is possible or not. So this is not set to be checked here because directly we are taking the each and everything in the domain part. So this cosec inverse x will become pi by 2 minus c. C is what? Sec inverse of x, and finally you can write here sec inverse x plus cosec inverse x will become pi by 2. Easily you can do the proof of this thing. Is it clear? So student, in this property fourth, a very simple thing is to be given. Sin inverse x plus cos inverse x will become pi by 2. Tan inverse x plus cot inverse x is again said to be pi by 2, and similarly sec inverse x plus cosec inverse x is again said to be pi by 2. Somewhere any of the changes is to be required in any kind of equation. Suppose we have to just change the cos inverse into sin inverse, then somewhere this cos inverse is to be get written as pi by 2 minus sin inverse. Similarly, this cot inverse x is to be get written as pi by 2 minus tan inverse. So suppose these type of changes are to be applicable in any of the question, then we can apply this property, and just we have to apply the property to simplify the answers. Is it to be clear? Generally this property is to be used to solve the basic kind of equations. Some inverse trigonometric equations are also to be included in our syllabus, and we will just simplify that equations, but where only the use of these properties are to be there. So we have to keep in mind these properties, and according to that we have to just process. So student, in this video just we are discussing the two property number 3 and 4. Already the basic property number first and second we have already discussed in the previous lectures, and now the sum of remaining properties are also in this chapter. The basic idea related to the properties is very important because the question is to be coming from this section from the properties always. So we have to keep in mind each and every property, and the miscellaneous questions I will just we will simplify at last after just finishing the each and every property. Though some properties are to be also there, so one or two lectures are we have also consumed in this particular process, so that when we have to do the attempt the exercise, then there should be no problem. Because now the thing is most important thing is we have to just write each and every property, and we have to see the proof of each and every property just by using the trigonometric functions, their identities, their formulas, just we have learned in the previous class. And student, in this whole class 12 entire calculus, entire you can say that the differentiation process, or in each and everything the trigonometry will be very important for us, and somewhere some of the questions related to the inverse also to be there. So we have to keep in mind the concept of inverse trigonometric functions and its formula, as well as the formula of trigonometric functions also, so that in the remaining part of this class 12 mathematics there should be no problem in front of you, you will face. Is it to be clear? So in next video student we will meet with the some more properties, but before that you have to just write down each and every property before seeing the video, because one time if we have to see the video, then automatically in your mind these properties are to be coming. Then without seeing this part, we have to just write each and every property, and what is the proof of each and every property we can see this thing, and then definitely if we are attempting a question, then and the property will come in your mind and you can just able to find the answer. Is it to be clear? So thank you student, we will meet with the some more properties in the next video.